Hello everyone, welcome to my channel Physics Tricks. So let's have a detailed analysis of Newton's third law of motion. And what is Newton's third law? It is that every action has equal and opposite reaction, right? So Newton's third law has already been introduced in chapter 4, and that is if a body A exerts a force F bar on another body B, then body B exerts a force minus F bar on A. Right, so if you consider two bodies, right, so if this is A and this is B, if body A exerts a force of F bar, so if you consider F bar on this, then body B will exert the same force but in opposite direction, that is minus F bar, right. So as you can see over here, this F bar and this F bar magnitude wise same, only the direction wise it is different, right. So thus the force exerted by A on B and that by B on A are equal in magnitude but opposite direction. This law connects the forces exerted by two bodies on one another. So Newton's first law we have law of inertia, Newton's second law we have law of momentum, and Newton's third law we have the law of forces. This connects the forces, right. So as you can see, the forces connected by third law act on two different bodies, right? So these forces act on two different bodies, and that is the reason in free body diagram, one of the two forces will come. In free body diagram, one of the two forces will come. If you consider B as a system, this force will come. If you consider A as a system, then this force will come, right? So these two forces will never be in a single free body diagram, right? In free body diagram, there must be only one force, right? Okay. For example, suppose a table exerts an upward force N on a block placed on it. This force should be accounted if we consider the block as a system. That is what I told. The block pushes the table down with an equal force N, but this force acts on the table and should be considered only if we take the table as a system. So if you consider a table, and on this table we have supposed to be a block. If table exert a force of N on the block, then this block will exert a force of N on the table. So if you consider a block as a system, this N will come. If you consider a table as a system, this N will come, right. So this is what they are saying. Thus, only one of the two forces connected by third law may appear in the equation of motion depending on the system chosen. Right, the force exerted by Earth on a particle of mass capital M is mg downward, and therefore by the particle on the Earth is mg upward. So, if you consider a Earth and if you consider a mass M, this is capital M, then on small m supposed to be mg in the downward direction by Earth on small m, then on Earth due to small m we have the same force mg. Now some of you will say due to this Earth there is an acceleration in small m. Then due to small m, can there be acceleration in Earth? Yes, possible. So what is the acceleration of Earth? If you wanted to calculate, divide that force by mass of the Earth. Mass of the Earth, we know that 6,400, 6.6 into 10 to the power 26, I think 6.6 into 10 to the power 26 kg. So if you just solve this, you will get acceleration a very smaller value, right? But yes, acceleration will be there, right? The downward force on the particle will cause acceleration of the particle, and that on the Earth will cause acceleration of the Earth. So whatever force on the Earth is there due to this small m, due to that some acceleration will be there. Newton's third law of motion is not strictly correct when interaction between the two bodies separated by a large distance is considered. We come across such deviation when we study electric and magnetic forces. So we'll study about this in electric and magnetic forces. Working with a tension in a string. The idea of tension was qualitatively introduced in chapter 4. Suppose a block of mass capital M is hanging through a string from a ceiling. So we have, this is the ceiling, and one block of mass M is there. and if you consider a point A. So at this point A, if you want what is called as the tension, so always remember at this point, from the bottom end, this string wanted to pull this object, isn't it? And this string wanted to pull this object. So always remember, tension is a pulling force, right? So from the object, always in the away direction. From the object, always in the away direction, right? So this is the tension. Equal in magnitude, opposite in direction. We have equal in magnitude, opposite in direction. Consider the cross section of a string at A. The cross section divides the string into two parts, lower part and the upper part. So this is the lower part which we have, and this is the upper part which we have. Okay, the two parts are in physical contact at the cross section at A. The lower part of the string will exert an electromagnetic force on the upper part, and upper part will exert an electromagnetic force on the lower part. According to third law, these two forces will have equal magnitude. The lower part pulls down the upper part with a force T, and the upper part pulls up the lower part with equal force T, right? So lower part pulls down and the upper part pulls up, right? So that is what they are saying, and string on each other is called as tension. What is the tension in the string at the lower end? The block and the string are in contact at this end and exert electromagnetic forces on each other. The common magnitude of these forces is the tension in the string at the lower end. What is the tension in the string at the upper end? So same thing at the upper end, if you want, it is just pulling this ceiling, and at the lower end, if you take, it is just pulling this mass M. So this is what you have to remember. So tension is a pulling force, and it is always away from the object. So no need to remember anything in this. Only thing you have to remember is this one, and that is, if you consider an object, from the object you have to consider the away, and from the ceiling as object, then you have to consider away. So I hope this is clear to you all. Now if anyone has any doubt, you can always comment in the comment box. I'll try to reply to your comment as soon as possible. Thank you so much.